Hello, Warhawks. Welcome to another edition of Carnegie Math, Chapter 7.3, Triangle Congruency by Side, Side, Side. So today we're going to be talking about congruent triangles and how if triangles have sides that are all the same, then they're going to be congruent, which sounds silly because of course they would be the same if their sides are the same. But what that allows us to then also know is that all the angles are the same. So we abbreviate side, side, side congruency with SSS. That's how you usually see it. And what it says is if all of the corresponding sides of two triangles are congruent, then the triangles themselves are congruent, which means also that the corresponding angles will be the same. Here's an example of a triangle. I guess this part of the chapter kind of goes through and proves how triangles are still congruent, even though they look differently. So they have us doing some rotations and some reflections. So I'm just going to go through how they're going to solve these problems in this section. So we're going to rotate this image 90 degrees clockwise, and we're going to show the sides are still the same length. So remember, clockwise, we're going the same direction as the clock. So right now we're in this quadrant. So if it's rotated 90 degrees, everything's going to come down to this quadrant down here. Another thing that we want to look back to is our rules for rotation. Remember that we're going to take all of our points, and when we're rotating 90 degrees, we're going to flip them. So instead of 4, 8, I'm going to have 8, 4. Instead of 9, 8, I'm going to have 8, 9. And instead of 9, 2, I'm going to have 2, 9. So there's my new points. However, think about this for just a second. Remember that we're going from this quadrant clockwise, so everything's coming down here. In this quadrant down here, we have a positive x value, but our y values are negative. So I want to leave the x values positive. I'm going to make the y values all negative. And now I'm going to plot this triangle. So we have 8, 4. There's 8, 1, 2, 3, negative 4. It goes right there. 8, negative 9. There's 8. Down here's negative 9. And then we have 2, negative 9. So now I'm just going to go ahead and connect these. There we go, to form a triangle. And we have our two triangles. This image has been rotated down here. Now I want to see if the sides are still the same. Well, we can measure the sides if we had a ruler, or we can actually, with these, we can just count. So look at the length of this side. We go from 4 to 9. I can count. It's 1, 2, 3, 4, 5. It's an easy case scenario because it's just on one of the x or y lines. I can also count this one. It goes from 8 down to 2, so it's 1, 2, 3, 4, 5, 6. This one's not so easy. However, with this one, we can just use Pythagorean theorem because we have a right triangle here, which is what I would recommend that you use anyway. So I can do 5 squared plus 6 squared is going to equal that third side squared. And you'll notice too, the difference between 4 and 9 is 5. The difference between 8 and 2 is 6. That's where we get those numbers. 5 times 5 is 25. 6 times 6 is 36. We add those together, and we get 61. And then we just want to take the square root of 61. The square root of 61 is 7.81. So that's what our third side is going to be there, 7.81. And then we look at this other triangle. So let's see if the sides are still the same. We can count these. So we go 1, 2, 3, 4, 5. We can count this distance, 1, 2, 3, 4, 5, 6. So far, so good, and that is a right angle there. So we could use Pythagorean theorem again. Now you can already see that the sides are going to be the same. We have 5 squared plus 6 squared, same thing here, is going to equal c squared. So we will again get 7.81. There we have proved that all the sides are the same. So we have what we call side, side, side congruency. Okay. What we would also know between these side, side, side congruencies is that this angle and this angle would then be the same. That these two angles would be the same because the triangles are congruent, and that these two angles, the 90 degrees there, would also be the same. Okay, let's look at one more example here. So that we have a reflection of triangle ABC over the y-axis to create triangle XYZ. And we want to prove that they're the same by side, side, side. So we need to see what the length of these sides are going to be. So I'm going to find AB first. Oh, actually, I'm going to find BC first because I can just count it. It goes from 3 up to 10. So 1, 2, 3, 4, 5, 6, 7 is that length. Then to find AB, I'm going to go from 6 to 10. Now, again, I'd say just use Pythagorean. Make it a little Pythagorean here. The distance from 6 to 10 is 4. So we do 4 squared. The distance from 8 to 3 is 5. So we do 5 squared. Multiply those out. We get 16 plus 25. And we add those together. We get 41. And then the last step, as always, is just to take the square root. So we come down here, calculator, 41 square root 6.4. So this side length was 6.4. Now I need to find this side length here. Again, I'd use Pythagorean. We're going from 6 to 3, so the distance there is 3. And we're going from 8 to 3, and that distance is 5. Now, if you put in the distance formula, you'll get the same thing. I just like to do Pythagoreans. 3 times 3 is 9. 5 times 5 is 25. We add those together, we get 34. And then we're going to take the square root of 34. 34 square root 5.8, rounded to the nearest 10. So we'll put 5.8 is what this side's going to equal here. Now let's see if we can prove that these two triangles are the same. Over here, I can just count this distance. 1, 2, 3, 4, 5, 6, 7. And since we reflected it, all the values are the same, just the x values have changed from positive 6 to now this is at negative 6, but still positive 8. Y is going to be at negative 10, but still positive 3. And Z is going to be at negative 3, but still the Y value is positive. So let's go through and set up how we're going to find out if these are congruent. Well, we already have 7. Those are the same. There's one side that's the same. So we do the distance from negative 6 to negative 3 again is 3 squared. The distance from 8 to 3 again is 5 squared. So look, we have the same thing here as we have over here. Those are going to equal each other. So we already know that this is going to be 5.8. So again, we have another set of sides that are going to be congruent. Then lastly, we check to see the distance from negative 6 to negative 10. It is 4, so we're going to do 4 squared. The distance from 8 to 3 is 5. And then we see that again, we have the same exact thing there as we had over here. So this distance will be 6.4, which means that we have 3 sets of congruent sides. So now I'm going to show you what we do next. Since we know that these triangles are the same, I'm going to say triangle A, B, C is congruent, there's our sign for congruency, to triangle X. And it's important how I list this. I said A, so I must say X first. And then I went from A to B, which was the 6.4 side, so I must go from X to Y, and then lastly to Z. And I would say that this is true by side, side, side congruency. They're exactly the same. Now, what does that really mean? Well, it means that our angles are also going to be the same, or angle A will be congruent to angle X. It means that angle B will be congruent to angle Y. And lastly, angle C will be congruent to angle Z. Okay, so that's what we can prove. Now we know those angles are the same. So if we had a measurement for Z, it'd be the same thing for C. If we had a measurement for Y, B would be exactly the same. All right, I'll see you in class, and have a good day.